Hello, my name is Tibesigwa Dankan from CodePile. I'm excited to present interpretable machine learning for predicting students' performance in STEM subjects in Ugandan secondary schools. The acronym STEM stands for Science, Technology, Engineering, and Mathematics. The contents of this presentation is going to be the introduction, problem statement, related works, research questions, objectives, the methodology, conclusion, future research directions, references, and acknowledgement. With the introduction, interpretable machine learning has gained an increasing attention in recent years as it enables development of more transparent and accountable predictive models. Machine learning has the potential to provide valuable insights into the factors that influence students' performance, particularly in STEM subjects. By using interpretable machine learning techniques, it's possible to identify the key factors that influence students' performance in STEM subjects. We shall explore the use of interpretable machine learning for students' performance prediction in STEM subjects in Ugandan secondary schools with a goal of improving access to education and opportunities for students in these subjects. The problem statement. There is a lack of interpretable machine learning models for student performance prediction in STEM subjects in Ugandan secondary schools. So why is this a problem? Well, the existing traditional methods do not provide transparent predictions of students' performance, and they are often subjective and may not accurately predict future success. However, the use of interpretable machine learning in education is still relatively new in Uganda. There is a lack of understanding and expertise in this area. So to address the above research gap, our research suggests support for implementing an interpretable machine learning model for predicting students' performance in these particular subjects. Our related works. Interpretable machine learning for student performance prediction in higher education by AAA Gamma at 2014. This study used a decision tree and rule-based models to predict student performance in a Brazilian university, and found out that these were interpretable machine learning models were able to achieve high accuracy and were more transparent than the more complex models. Predicting student performance in higher education using interpretable machine learning models by SR Kotsiantis 2006. This study used a number of interpretable machine learning models, including decision trees, rule-based models, linear regression, to predict students' success in a Greek university. The authors found that these models were able to achieve good performance and were able to provide insights into factors that influence students' success. Research questions. How effective is a machine learning model at predicting students' performance in STEM subjects in Ugandan secondary schools? What's the potential impact of using machine learning model on improving students' performance in STEM subjects in Ugandan secondary schools? What are the challenges and the limitations of using machine learning for predicting students' performance in STEM subjects in the Ugandan secondary schools. What is the potential of using interpretable machine learning to support decision-making in the context of STEM education in the Ugandan secondary schools? Research objectives. One of our objectives is to develop and evaluate a machine learning model that can accurately predict students' performance in STEM subjects in Ugandan secondary schools. Another objective is to assess the impact of the machine learning model on improving students' performance in STEM subjects in the Ugandan secondary schools. To identify the potential challenges and limitations of using interpretable machine learning for students' performance prediction in STEM subjects in Ugandan secondary schools and suggest ways to overcome them. To explore the potential for using interpretable machine learning to support decision making in the context of STEM education in Ugandan secondary schools. The methodology, we are in the process of collecting data, and this is the first step, and usually the first step in when implementing these models. So as I said, we are in the process of collecting data, and then we are going to do a data cleaning. This is to eliminate errors and ensure the data we are using is more accurate. And then from there, we shall be extracting out the features that we will use to develop these models. From there, we shall proceed to the development of the model. Under development of the model, we shall split the data into a training data set and a testing data set. And then we shall apply the machine learning algorithms on the training data set. And then from there, we evaluate the trained model. We validate the trained model, not evaluate. Then after that, we shall test to ensure that the model is performing as we intended. Before that, then we shall have to visualize the model in a web-based application, which we will then deploy to production. Expected results and contribution. One of the contribution of our research is going to be improve the accuracy. This is to reduce the number of false positives and false negatives, whereby the false positives could be the number of students who are expected to pass and failed, and the false negatives could be the number of students who are expected to pass, fail, and then passed. Increased transparency is another contribution our research is going to make. This is to ensure that the machine learning model is providing insights into the factors that influence students' performance, which the educators can understand the challenges that students face. Improved fairness. This model is going to predict each and every student's performance, irrespective of their background. And then one of another contribution of this research is going to be enhanced decision making. This relates to the second point of increased transparency. In conclusion, it's important to consider interpretable machine learning models when predicting students' performance, as the understanding of factors that contribute to students' success can help the educators and policymakers make informed decisions on how to support students that are struggling. The future works. Our research is currently based in Uganda, we intend to extend it to other East African countries and then later on to the whole African continent. Acknowledgement, I thank the Almighty who has kept me alive and has kept me alive together with my group members and given me the knowledge, the guidance to make this research. I would also like to extend my sincere appreciation to my supervisor, Mr. Galwango Marvin, for his guidance and tireless efforts to ensure that we do the right work. These are the references that we did use when making this research. And thank you for listening.